We've been doing a great job with equations, using equations in slope-intercept form, y equals mx plus b. But in this lesson, lesson 42, we're going to interpret linear functions, which means we're going to have equations written as functions. F of x is equal to mx plus b. In this lesson, we're going to learn how to identify the variables, which is f and which is y. So what's our input, what's our output, so we can actually express it as an equation or as a function. And we also need to be able to identify the slope as well as the y-intercept. Let's look at our first problem together in this model. Tanya is making greeting cards. The data table below represents the amount she spends in dollars, so that's f of x, in terms of the number of cards she makes, x. So that's our input. X is the number of cards. And the output on this table is the amount she spends, the money spent. All right, there's our input, there's our output. It's already there in the context of the problem. Here's what we're being asked to do. We're going to write a linear function to represent the data, and then we're going to explain what the slope is and what the y-intercept is in the given context. So we'll start with the first one. We want to be able to rewrite this as a function in this form, which means we need to find m and find b. So that's going to be my plan. I'm going to use 2 points to calculate m, and then I'm going to substitute, once I have m, into my equation to solve for b. All right, so let's identify 2 points. We already know what the slope formula is. We've seen it so many times by this point. So let's identify which points we want to work with what coordinate pairs. Any 2 points will work. You can choose any. I'm just going to choose these two because they have the friendliest numbers. So here's my first set of coordinates. Here's my second set of coordinates. And again, doesn't matter which ones you choose. I just didn't want to work with decimals for today. Let's sub in. y2 is 12, so 12 minus 9 over 10 minus 6, which simplifies to 3 over 4. And I can't simplify that anymore. M is equal to 3/4. Okay, now that we have m, let's figure out what the b is. So already we have the beginning parts of our formula. F of x is equal to 3/4 x. Let's find b. I'm going to write that formula in. I'm actually going to put it in y-intercept form just because of the coordinates we have. Y equals mx plus b. We already know what the m is, 3/4. So again, I'm just going to choose a coordinate. I'm going to choose this one that has the simplest numbers. So when y is 9, 9 is equal to 3/4 times 6 plus b. Use my order of operations. 3/4 times 6 over 1 plus b. 9 is equal to 18 over 4. And let's simplify that out a little bit more. And you get 9 is equal to 4.5, 4.5 plus b. Okay, let's isolate for b now. And 4.5 is equal to b. And so I have the last part I want. 4.5 is positive, so I'm going to put my linear function as f of x is equal to 3/4 x plus 4.5. All right, so what do these numbers mean in the context of the problem? Well, the 4.5 is when x is equal to 0. So when I've made 0 cards, b is equal to 4.5, or how much is spent when she makes 0 cards. In other words, that's our initial value. Her initial cost is $4.50. So notice I'm putting that into context as we're talking about money, and that's what the units are. So 4.5 represents $4.50, and that's how much she spends from the very beginning before making any cards. That's her initial cost. So what does the 3/4 mean in this context? 3/4 X. That means for every card she makes, she is spending 3/4 of a dollar. M is equal to 3/4 for every card made. $0.75 is spent. All right, so notice what I did there. I just turned 3/4 of a dollar into 75 cents. So that is how I am figuring out how much money is being spent. All right, so this again was a little bit tricky because I had to understand what those fractions meant, what those rational numbers meant in the context of this problem. But let's hit pause so you can jot this down and put this into your notes. Here's another problem. I'm going to read it with you, and then I'm going to stop to give you opportunity to hit pause, try and solve it, and then I'll reveal the answer at the end. So let's go. Last weekend, Emma sold lemonade at her yard sale. The function P of C is equal to 0.50C minus 9.96 represented the profit P of C. So let's put this in here just so I can rewrite it. P of C is equal to 0.50C minus 996. So we're calculating profit as a function that she earns from selling C cups. So we can see why that's an input. For every cup she sells, she makes money. Okay. Sales are strong, so she raised the price for this weekend by 25 cents per cup, which function represents her profit for the weekend. All right, so let's try to figure out what this could mean. She raised her price by 25 cents per cup. Hit pause and try to identify which function represents an increase of 25 cents per cup. All right, let's do the reveal. If you had D, you are correct. That is the right answer. So what you're looking for was this cost over here being increased by 25 cents. We're increasing the rate. So what that means is instead of 50 cents, you're just going to add another 25 cents to it, and that's why you get P of C is equal to 0.75 cents, and that represents an increase from 50 cents per cup. All right, great job. I do have a follow-up question. What does the B represent in this problem? The minus 9.96. So think about this as a function where this is a function to calculate profit. So what could minus 9.96 mean? What do you think? So if she sells 0 cups, before she sells a single cup, her profit is negative $9.96. So she's already in the negative before she sells a single cup. So this again represents initial cost. That's the initial investment. So that the money they've put in before they've started the business. And that's what the B represents here. It's the initial. All right, That's it for today's lesson. I hope you found this super helpful. Again, here was our look fors in this problem. We wanted to be able to identify the variables of x and y, or for f of x, and to figure out what they represent. And you can see how I did that as I read through the problem and annotated. I tend to write down the equation and write down what each of the variables mean. My b is typically an initial clause. It's like a starting point, because that is when x is equal to 0. So before you even put in anything. And then going into figuring out what our function is and what the c is equal to. Awesome. We can use the information as given. As long as we have 2 coordinates or 2 points, 2 data sets, we can identify what the slope is using our rate of change formula or our slope formula. And we can also identify what the y-intercept is from the problem, whether looking at the data set or by just substituting 2 data points into our equation and solving for b. That's it for today, Math Marvels. I will see you in the next lesson. Be well.